I work for a company called Ascension IT. So we basically build a platform that helps the telecom providers to shift from the standard telecom guys to a digital service provider. So when you're shifting from a standard telco to a digital service provider, you need to go through this whole from the virtualization to cloud, and so we help them on that journey. So our platform does that. So basically, I want to have a small chat about the cloud native security and best practices. So I'm not going to talk a lot about cloud native, what is cloud native, because you guys already heard a lot about cloud native. And I just want to highlight a few things. Like, one is that it is not only the containers, it includes the serverless as well as the VMs as well. And on the pro side, I just highlighted one thing, which is the fast time to market. So one of the key thing is you are able to quickly shift stuff to the market. And on the con, I have just highlighted the security is a bit of an issue, right? So because it's complex, and you push things very quickly to the market, and the security becomes a very big problem if you don't address it properly. So when it comes to the cloud native security, so we have like the four C's, right? So on your at the corner you have the cloud, which is not only the cloud. It could be your data center, it could be your on-prem setup. It could be anything that provides that cloud infrastructure, right? And then you have the cluster. In this case, we just highlighted the Kubernetes cluster, and you have the container, and then you have the core. So these are the different levels of security that you need to think about when you're looking at the cloud native security. All right. So if you look at what a traditional environment versus a cloud native reality, right? So in a traditional environment, you had a very long release cycle. You don't get stuff, every week releases or something like that. You don't get it. You have to wait till 3 to 6 months to get stuff come out of it, and then the code is mostly proprietary. So you had a pretty standard way of doing things. You had the libraries and all that, and the workloads are persistent, right? And because you save the sessions or data, whatever you basically save it, it's very persistent. And you have the isolation, security isolation through either hypervisor, or you can do it with the hardware level isolation. And you have a permanent IP addresses. Whereas when it comes to the reality of cloud native, your release cycles are short. So you basically do a CI/CD very fast. You automate the whole process, right? So then you have to think about how to. There's a process called bringing your security shifting towards left, and compared to always the proprietary code, you have open source code everywhere, right? So you need to understand how good is or how vulnerable is that code is, and we just pull stuff from the public image. We don't know how much of vulnerabilities it has, so that's there. So you have a supply chain risk also, right? And unlike the persistent workloads, you have a ephemeral workload. So basically the information is injected on context, right? So that is another area that we need to think about securing. And so we have basically a shared kernel. So the isolation we had earlier, we had hardware isolations and the VM isolation, but here it's a shared kernel. So you need to give a least privilege as much as possible to the system. And also, unlike the permanent IP where you could say, okay, from this IP if you get a request, block it, very simple. But now you have a dynamic IP, so you need to have a different mechanism. So one mechanism is the identity-based protection, right? So we spoke about eBPF and all that. That comes into the picture very well. All right, some of these acronyms, right? So I'm just gonna run through very fast. So basically, let me run through here. Okay, so you have basically main 4 things, right? So you have the workload, you have the identity, and you have the cloud side or the Kubernetes side, and then all of that is called the cloud native application platform, right? So you have the application as well as the cloud together, right? So that is where you need to basically protect it, right? So in the application components, right? So you have a data plane, your workload. So workloads could be like it could be serverless, it could be VMs, it could be containers, whatnot, right? And then you have the identity and access side, and you have the management side, and you have the platforms, which is your Kubernetes platform or whatever does the orchestration part, and the network and the security side. So so the four things we spoke about when we talk about the security, right? So one is the workload protection. So workload protection basically focuses on the workload itself, right? So it basically protects your VMs, protects your containers, and protects your serverless component. And then you have something called cloud security posture management, basically like to see as a snapshot where you are in terms of the security. So you can look at your data management platform as well as the network security side. And then you have the similar one, you have a Kubernetes security postures, right? So you can look at the what Kubernetes, where it stands, right? So that is another area. And then you have the entitlement. So basically access and identity management to make sure who gets what privilege, including people as well as the services. So the access and identity management basically enforce that access control. And then you have the detection and response, right? So basically in this concept we are looking at as a whole to detect it and go through the response mechanism. What would you take it afterwards, right? And so basically the cloud native application protection platform means all of that together. So in the cloud native application protective platform, you have all of these CWPPs, the posture management, the identity and access side, as well as the detection and response side as well. Okay, so some of the attack vectors, how can you can get compromised, right? So one of the attack vectors is, so you have the, if you look at the in the cloud scenario, you have the identity part, you have the network control, servers, and the data, right? So one aspect is that you could get a network breach, and then secondly you could get a unauthorized resource access. So these days you see a lot of passwords has been come out, or the a lot of credit card information has come out. So that is where you don't look at these aspects, right? So then security misconfiguration can give you a superb problem. Similarly, and then you also have the exploit and vulnerability aspects of the servers and services that you provide as well. Are we following, or are we okay? Okay, so if you look at the Kubernetes in specific, right? So Kubernetes attack vectors, you have a you could attack at the API level. So if you are not secure your API and things like that, so the attacker can come from there, or malicious container image. So your container image, so like remember now we are using a whole lot of open source containers and anything that is coming on public, right? So if you just pull it and put it there without checking what's the vulnerability, whether it has any malicious code and stuff like that, that's another area that you can get exploited. And apps themselves can have vulnerabilities as well. And then I think Nilesh and everybody spoke about the secrets being injected, right? So exploited app can access a very base 64, those very simple secrets. You might be able to get access, and then you will have a lot more access in that. So securing it, encrypting it, those are really important. And also container runtime misconfiguration. So if the container runtime has been misconfigured to sort of give more privileges, like have a very host privilege level and all that, so that could also, whatever the app, the container that's going to run on top will have all the access as well. So you need to make, when you create your infrastructure as a code, you don't put all these misconfiguration as well. Yeah, so the container workload. So similarly, on a container workload, on a previously I spoke about on the Kubernetes as a Kubernetes clusters attack vectors. In the container itself, you have multiple attack vectors as well. So you have a the first one is the operating system vulnerabilities. There, if you have not patched them and all that, you will have a entry point there, and you have the vulnerable applications, insecure images, privilege escalations, misconfigurations. So all that can give you to provide an attack vector for a hacker to get your infrastructure compromised. So some of the best practices we spoke about: shifting security to the left, right? So these are standard, the 6 phases of your software development, right? So where do we where do we normally do the security? Where do we, like in the normal scenario, where do you think we implement security? Yeah. So basically, like right after deployment, right? So we deploy the system, and then we do a vulnerability assessment or a penetration test, and all that we do it over there, right? So that is not good, not going to be useful anymore with the whole cloud native infrastructure, because you keep on producing new things as well. So you need to address this at the beginning. So at the design stage, at the development stage, you need to think about the security. Not only there, actually speaking, multiple places, right? So at the staging, deployment, all those places also, you need to look at security. But there's a whole lot of emphasis towards the, at the beginning of the phase, right? So when you bring that in, when you bring it towards this way, you will address the security early and make sure those sort of problems are not arise in your deployments, right? Okay, how are we the time? Okay, right. So so basically, in the whole cloud native application, like securing a cloud native application, so you basically code it, build it, deploy, run, and finally response and do a forensic analysis and all that incident part, right? So one way you could do it at the code level, where you basically create the infrastructure as a code, you validate it, right? You make sure the passwords are not submitted to the Git. So you have a validation where it doesn't let you commit stuff to the Git, or if it is already there, you could actually do a pull and then do analysis as well, right? So that actually comes on the build phase, and prioritize also your the things are in use. So security is not something that you like over architecture it or over engineer it and then try to get the whole thing in one day. It's a process, right? So you go with step by step. So first maybe you attack the ones that are already in the system, and then you prioritize on those things, and then slowly you can implement the whole security stack. Yeah. So similarly, at the deployment phase, you have an admission control. Kubernetes has an admission control gateway. So you something like that. You could say, okay, if some you check it. Here. So you basically, when somebody try to do a deployment, we do a admission control, right? So then it will go and check whether the image is up to the standard what we need, whether there are any vulnerabilities, blah blah blah, all that. If it is not, we'll reject it, right? So you could have a admission control like that. Yeah. So basically, give the give the access and identity management side, the threat detection and all that. Okay, so when you are pushing the the image into, so the developers will develop it and push it to the development registry, right? So then that can be push it to the dev cluster, no problem, right? But once it is go to the QA, we can make sure that image is signed. So if any image comes to the QA registry which is not signed, we can reject it, right? So image signing also will reduce a lot of unwanted attack vectors that can compromise your system. So similarly from the QA, when it goes to a production cluster, we do another signing, make sure the image is signed. If it is only signed, we do the deployment. So gatekeeper pattern, so we spoke about this. It's a good practice, admission control, and I think Nilesh spoke about having a your base image like something like Alpine. Keep it small, has very little vulnerability. Start with something like that. So you could basically have a less vulnerable image, and also maybe from trust sources like I don't know, maybe Red Hat or something. I don't want to talk about too many vendors, but maybe a trust source. So you develop your own thing, base image. After running through so many things, that will reduce your attack vectors and all that. Yeah. So the other thing is this has to be a continuous process, right? So basically, the cloud posture management and the Kubernetes posture management. So we will check it every time when you are running, and if there is an issue, so you fix it, right? So then you run your whole infrastructure as a code part, you fix it and make sure that those things are applied. Okay, so basically when it comes to security, everybody has a persona, right? So from the developer to platform engineer to DevOps to DevSecOps, everybody has their role in contributing into security. So developers has to make sure fix vulnerabilities, and so everybody has their role. So they all have to work together, and in that whole cloud native development and life cycle. So these are the areas that different personas get fitted into the system. So developers also in terms of the security, right? So in terms of security, they falling at the code level, and the security architect have to from the build phase to the end, they have to sort of get involved. SecOps get involved after forensic side, and the DevSecOps and platform engineers during deployment and runtime running areas. So that's very very speed run of my security. So basically, I mean, in conclusion, right? So the security has to be a cloud, especially cloud native security, has to be a collaborative effort. So it has to be, you have to have the dev guys, you have to have the security guys, you have to have ops. Everybody has to work together and push this into the early as possible in your life cycle, and make sure not unwanted stuff. We are having a lot of problems because people keep committing the passwords and unnecessary sort of secrets into the Git, right? So those sort of things has to stop. So you can slowly put control. So it's actually a process. Like you see, like rather than having a one platform or something that a lot of CIOs wants like a one platform that will make sure they'll get zero vulnerabilities, which is not possible at all. You have to be very practical, right? And then, because otherwise you will spend a lot of engineering doing the platform and everything, and like hardly any time you are actually working on your product, right? So you have to have the balance. Work, like if you are already work on the product and it's already in the it's running, then look at where you are and in your that whole journey, right? And then start from there. Maybe have some controls in place, have some observability and all that, and monitor it and things like that. So yeah, so basically what makes sense for your business, right? So go in that practical way, and of course you have to look at the finally it has to be a bigger decision, because like too many times we have seen so much of passwords and so many data has come out, and now you are getting a huge fine and all that also, right? The data privacy and all that. So you need to really think about, especially in the whole, because it's so complex and all that, you need to really think about the whole picture, where you basically at least mitigate your risk looking at all the different attack vectors, right? Okie dokie, thank you very much.